Hi everyone. Today I just wanted to show a different resist. I know we talked about vinyl resists in our last workshop session, but a few of you have asked about things that had really high detail and how do you address that with vinyl, because it's a pain, as many of you have probably figured out, to be able to like weed out those small details. And there will be instances where you need to have this maximum amount of detail, and both fine and larger detail. And so the material that I typically advise students to use as a resist in those instances is either PNP, which is press and peel blue, looks like this, or E3. And I believe right now Rio sells E3 paper. It's a white paper, looks something like this. It's got a kind of glossy feel to it, not quite as glossy as the back side of a PNP. But I'm going to talk primarily about E3. We've been using it recently, and I think it's actually a lot easier to use than PNP blue. PNP blue is always a little bit temperamental, I felt, in its use, and so again we've switched to E3 and we'll discuss it. So both of these resists are considered a toner resist. So what's happening with this paper is that we're making a contact sheet essentially that has a full page of whatever we want to etch. So in this case I'm doing something I usually like to show, like a comic book or something that has either text or tons and tons of fine detail as a demonstration of how effective this resist is. And so in this case I make a contact sheet that's just on regular paper. Now you could print this out on an inkjet printer if you wanted to. In my case I've used just a laser printer that I have here in the studio, but for the contact sheet it could be inkjet if you want, but the images do need to be high contrast. So it needs to have strong blacks and strong whites. This is not good for grayscale. So a lot of times I'll have students adjust an image. If they had a photograph, I might actually have them bring it into Photoshop and adjust the threshold on that, and it'll give them a stronger black and white contrast image. And so that's what we're using here. In this case is just a comic book image. I could invert this so that my blacks were white and my whites were black, and then when I etch this, it would, anything that's black essentially is going to be protected. So in this case it'll etch all the white areas in the case of this image. So if I wanted it to look like this image, I would invert the black and white of the image. Text also will need to be mirrored. So you would need to mirror your image if you wanted to read properly, because we're going to apply this onto the surface of the metal like this, and then when we peel this up we want that text to read properly. So do keep that in mind, that if you're going to be using either PNP or E3, that you need to, and use text, that you need to mirror that text so that it comes out properly. The cool thing about making this contact sheet, again, even with an inkjet printer or laser printer, is that I eventually will use, since this is a toner transfer, we're going to be using a laser toner to print the actual sheet onto the E3. Okay, so we're using this again, this could be printed on an inkjet, but this has to be printed with toner. Okay, so that you have to use either a laser printer that uses toner or a copy machine. Now the interesting thing that I found is that our copy machine here at my school, it has an invert option. It also has mirroring options. So I can pretty much prepare this contact sheet, and I can use this contact sheet, and then I can decide if I want to invert that black and white, or if I want to mirror my text. I can do that all from the copy machine instead of having to do that in software, for those of you that want to get out of the computer as quickly as possible. So just keep that in mind. All right, so now again, whenever I go to print this on my copy machine, I'm just going to lay this down. I'm going to feed this into my my sheet feeder, my feed tray, and I will be able to print on it. Now, what's interesting is the old PNP, you had to print on a specific side. There was a shiny side and a dull side, okay? And you had to print the toner on the dull side. So you had to know which way your sheet feeder was feeding through your printer or your copier so that it printed on the correct side. The cool thing about E3 is that both sides are prepared to be used as toner, okay? So it doesn't matter which side you're printing on, it's still gonna work. So again, when I run this paper through, you get a package of this. I can't remember how many sheets they give you, but you get a package of this blank paper from Rio, and I usually try to handle it by its edges. You'll notice even how I've been handling it by its edges, because I don't want to get any oils from my fingers on the surface of that paper. So when I get it out, I'm very careful with it. I feed it in the machine and I print that out. And I do print a full page. Anytime I prepare a contact sheet, here's a bunch of student sample sheets, I try to fill that contact sheet so that I am not wasting any material, because I'm only going to be able to run this through, or at least from my experience, only be able to run this through the printer once. So it's not like you print a section and then cut that out and then rerun this thing. First of all, it's not going to feed properly, right? So I usually try to print a full page, and I try to do duplicates. So if I do have a mess up when I go to transfer this, I have an extra copy of that image. All right, so with this transfer, the most important part of the entire process is the preparation of the sheet that you're going to be using. And in our case, we've got a sheet of copper that we're going to transfer this onto, and I'm going to prep this by cleaning it. I'm going to prep this by cleaning it thoroughly with a piece of coarse sandpaper. Now, in this case, I'm going to use some 220, so that's quite coarse, but it's going to degrease it, and it's also going to give it a little bit of tooth for the toner to stick to. And from my experience, that was even key with PNP, that you wanted a little tooth to the sheet so that toner sticks more easily, okay? So we'll prep this, and then we'll transfer over to the next part of the demo. All right, so we've moved over to the sink. I like to use the sink area here in our studio to be able to prep my sheet. And you'll notice one of the things that I'm always looking for, and I always teach my students, is that if your water, as you run it over your sheet, pools, and it doesn't create a consistent large kind of meniscus over the surface of that sheet, you know that it's not clean, as there are oils present. So we know that we need to be able to see that meniscus form as a solid sheet. Now, I am using that 220 sandpaper. This is wet dry sandpaper. I prefer to use this paper wet if possible, and so I'm just going to kind of dampen that. And I usually fold this. This is a kind of a quarter sheet, and then I'm just going to sand that copper. And you'll notice immediately we start removing oxidation that just is from the copper setting out in the environment in the studio. And so it should start to look clean. And occasionally I can run a little water. Now this is the area where you want to be very methodical in terms of making sure that this piece of material has been sanded. These edges that you see that still have oxidation, that's going to be an issue if you're trying to get that transfer to take. So you'll notice that I usually flip the sheet and go the opposite direction with my strokes. gonna go back the other direction. And back the other direction again. Now we only need to do this to one side of the metal. The opposite side can remain just as it was. But you'll notice this time now when we run the water, it sheets across. There might be a little bit of oil there or oxidation on the edges, but this is going to be suitable for what we're doing. So then again, I'm just going to dry this off. I'll use an air hose. In my case, you could blot dry this. Do make sure that you handle it by its edges though. Don't start handling it by putting your fingers across the surface that we're going to apply the resist to. Okay? All right, so for the next step, we've got our metal clean. All right, so it's been clean. We're handling it by the edges. We've got our resist. Okay, so we're going to prep that resist by cutting. And again, it never hurts to, at least from my experience, to make your image a little larger or your sheet metal a little larger than it needs to be. And I'm even, when I say a little larger, I just like to have extra material so that I don't have to worry about getting it perfectly centered. In our case, we'll take a look here and we'll see how we're looking. And I'm just cutting along the edge of the borders here. Again, I'm trying not to handle this though to where I handled over the toner areas and that I am contaminating that. I just like to be very particular with this. Okay, so now we know that this is gonna sit on here like so. We've got a little bit of a border, no big deal. I can always stomp shear that excess material off later. All right, so now that's prepped. Now, the next thing you're going to need is a heat source that will allow you to heat up the E3 so that the toner can be transferred. Now, if you read the E3 handout, I think it talks about taking and laying your metal down on a surface and then putting your transfer over the top of that and then putting like an old pillowcase over the top and then using your iron to iron as a heat press over the surface. I don't do that. I found that, and again, this may be a holdover from how I was taught, but I feel like the results it's harder to tell what's going on when you do it in that method. So what I do is I use my iron and I use it as a hot plate in this direction. I'm sure you could probably use like some sort of photo hot press as a way to transfer this. You could probably use like a plug-in griddle if you could tune your heat right. But in our case, we're set on permanent press between 1 and 2 on our heat. Okay, and you're going to have to just base this off of your iron. Every iron is probably going to be a little bit different in terms of its heat. And then we usually grip the iron as securely as possible. And this is an old iron. It's got a Bakelite plastic handle, so we try not to over tighten, but you do want this secured so it can't slip. You can see, like, if that starts to slip, I always try to get a little aggressive with this to make sure that it's going to stay locked in place. You don't want to be messing with a hot iron, flopping around while you're trying to do this. So that's why I'm wiggling this, making sure that, because I need to be able to rub the surface of the transfer, so I'm going to be a little bit of aggressive with this as I start to apply it. Okay, so we're ready to go. Now all we need to do is just plug in our iron. This will give us our heat source. And a lot of times, if you're worried about aligning that image, you can even take and some people take a little Scotch tape and apply a little Scotch tape to this. Again, don't get it on the underneath side though. We want that's going to get hot, right? So we'll just put it along like that. Now, again, I can do this before I ever heat up my iron if I want to kind of get in position before I plug it in. Okay, so I just turned on the iron, so we're going to be warming up that sheet. Now, this is a quite large sheet, and I'm just going to take a block of wood and kind of set on there as this starts to heat up. the time that it takes for the toner to heat up is obviously going to be vary in terms of the surface area, the amount of surface area you have in the sheet that you're using. So this one's a large sheet. It's going to take a while for this to heat up. So, but again, copper transfers heat very, very well, so it should heat up evenly. We are hanging off the iron just a little bit. Now the main thing you don't want to do is you don't want to move this. You don't want to like slide that image. If you do that, the toner that's already partially heated up will smear across the surface. And so that's why I'm making sure that I'm keeping downward pressure until I am absolutely certain that that transfer is hot enough that it's sticking in one singular location and not shifting at all. And there's a little bit of sizzling happening just from the moisture that was on the underneath side of my sheet. Again, that top of the sheet should be dry though, and it was. So wait for that to heat up. And then I have a burnishing tool. I like the curved burnishers with a curved tip. So this tool we're going to use to make sure that we have properly transferred all the toner over to our copper sheet. Okay, so I'm going to gently lift this and make sure that the paper is not lifting as well. I can tell it is on these corners where it's kind of hanging off. So I'm going to stay on there just a little longer so I can see the paper kind of lifting. On an image where you've inverted the black and the white, you're going to have, primarily black areas, a lot more black than I have on this particular image. Like, right, if I inverted this, I'd have a ton of black toner. It'll be primarily toner with just a few white lines. So it'll be easier to stick down an image like that than it will this image. This image, by having really small amounts of toner, it's going to want to lift in any place where there's no toner. So again, this is probably a more challenging image to do for a demo. Yours, most likely, again, if you've got primarily thin lines that you're etching, it's going to have a tiny bit of white showing and a ton of black. Okay. All right, now I can tell my copper is going to change colors a little bit too, right from the heat. It actually gets a heat patina that occurs. And so I can see now that this is adhered to it. So now what I'm going to cover up part of my image. I'm going to start this on this side, and I'm going to rub. Elizabeth may need to bring you in a little closer, maybe over the top, to kind of see this. Elizabeth Walton is doing our camera work today. You should check out her work. And she is helping out and assisting me in my studio this summer, so check her out.
That is very kind.
And so you'll notice I'm just using the curved part of this burnisher, and again, your metal is hot, so you have to be very, very careful. This can burn you if you're not careful. But what I'm doing is I'm rubbing that burnisher over that toner. You can see how it looks different, right? Paper, first of all, gets a little bit more of a sheen to it, kind of shiny. And then I can start to see the toner through the paper where I've rubbed, where I've burnished. And so I'm making sure that nothing's moving as I'm doing this. So I try to cover up as much as I can of that paper so I can get good burnishing action across that surface. Now, it was key that we didn't get bubbles, or air gaps in this. That's why I use a sheet of wood to kind of press against it. PMP, by it being more of a plastic-like paper, with like not plastic. It's like the old, what do they call them? Overhead transparency. It's got a transparency quality to it, right? And it's very plastic, and if your heat wasn't right, it would bubble up. It was just really tricky to use. And I think the E3 is way easier. I was very suspect of it in the beginning because it looks just like a piece of, glossy paper. But we have pretty much, switched over to this. Right, and all of these transfers have their origins in electronics, they were all used as ways to create circuit boards on copper-clad circuit board material. So you could create custom circuit boards. So Radio Shack used to cover or carry PNP, and then I used to buy it from Tech Inc. I have to special order it. Kind of pricey. I mean, E3 is a little expensive too in some ways, but you know, if you maximize your sheet usage. And you'll notice I'm kind of doing a cross-hatching pattern as well across my image. And I know we have, you know, the Spider-Man image has all these little webs, so I'm trying to make sure we get everything out to the edge. You see our copper changing color just from the heat. You have to be careful, your heat will transfer up this will get hot, you know, right here from making contact, repeated contact. So be careful. I am putting a lot of pressure down though. And that paper is just glossy enough on the backside that it kind of glides nicely over the surface. You shouldn't be, you know, using the tip and picking up and scratching through the paper. That would ruin it. Okay, so now it looks like we've adequately burnished our surface. So I'm going to use that piece of wood. I'm going to slide my piece of metal onto that piece of wood, and we're going to immediately go over to the sink. You'll hear it sizzle. I'm going to start running water over this. Now you could soak this in a bowl of water if you didn't want to have water running. I'm going to let that run for a little bit. I just went over and unplugged my iron. Now you're going to see what starts to happen is your paper is going to get saturated and it'll look different. Right here in the middle, it's still it's like splotchy, but we're starting to saturate areas of the paper. And so what we're looking for is for all that paper to become saturated to the point that we can start to peel it up. Now I'm not going to start yet. I want to fully wet that backing. So the idea here is that we're basically dissolving the paper, and what will be left will be the toner attached to the surface of the copper. You see how we still have some white, you know, whitish areas here. And again, you could put this in a bowl of water. I do think that kind of shocking the piece is important here. I don't let it cool down. I bring it right over the sink and kind of quench it. And I think that helps with that separation. And then you'll notice that I can start to peel this sheet, and it'll come up in whole sections in some areas. Other areas it won't. That's fine. I go ahead and peel off what I can as a sheet. And I don't want this to go down my sink anyway, right? So I make sure to just throw that in the trash. And then we're going to further saturate, you know, the rest of the paper, and then I can start to lift a little bit more. And this time, right, we're going to get sections. So don't let that go down into your sink and clog it up. Make sure you put a strainer or something over your. All right, and then as I do this, I can start to get a little bit more aggressive. I can just use my thumb and I can peel that backing. And again, I'm trying to catch this so it doesn't go down my sink. And it's amazing. You can get pretty aggressive with your thumb, you know, peeling that up. You just don't want to scratch the toner. That's the main thing. So I'm just peeling up that paper. I'm going to throw this paper off to one side here in my sink. Now, you want to make sure you get everything removed from the areas where there was white, right? So I'm going to use just a standard toothbrush, an old toothbrush, and I can start to use that toothbrush as a way to scrub away. And I'll show you what happens when this dries out. You know, if we let this water drip off of there, you'll start to see these white areas. You have to make sure you get that clean. It's kind of hard to see probably on this, but I'll show you. I'm just gonna blow on that a little bit. You can still see white areas like there, and there's still some stuff here, and there's some areas in here that you can kind of see that the sheen is different. So there's clumps of paper there. So we got to get that out of there so that the etch can occur, right? We're trying to make sure that anything that's supposed to be exposed copper is truly exposed and is not covered by paper. So I usually just have students you know, scrub it really well. And again, you could soak it longer. Eventually, if you soaked it for a long time, it would lift that, dissolve off that paper. I'm just in a hurry here for the demo, so. Okay, that's pretty good. So that's an example of using E3. You can see that we get incredible detail, line work. This would be great if you were drawing a black and white image and you wanted to transfer that drawing. This would be a great way. You can get really fine details. The most important part is that it's high contrast. It needs to be strong blacks and strong whites. And like I said, you can get an amazing amount of detail. Can you imagine having to weed all that, right? It'd be impossible. You know, if you were trying to vinyl cut this, it's just not the right tool for the job, right? Or the right material for the job. So in our case, the E3 is perfect for this application and allows us to get a really nice resist and a really nice image. Now, a couple things to remember. E3 does not work very well with aluminum, specifically the chemical that we use to etch aluminum, which I'll be showing you. It does not, that chemical is pretty violent in that it attacks the toner quickly and it starts to lift it. So I don't recommend that students use E3 if they're going to be using etching aluminum. It will transfer fine, but you would want a much more diluted version of our solution that we make so that it etches slower and isn't quite as aggressive. So it'd be a much a more prolonged etch instead in a diluted solution. But this works fine on brass, nickel, copper, you know, those are the main metals, bronze, new gold. You could use this E3 on all of those. And then again, you just use the appropriate etching solution. Works fine in ferric chloride, works fine in saltwater etch. So nitric acid will hold up, or it'll hold up to nitric acid as well. So again, great. It's a great resist. This toner resist for anything that's high detail with fine line work. And so eventually we'll throw this in and we'll put this in through our saltwater etch so you can see what that looks like.